So the last piece of the puzzle that we're going to cover today is going to be the test driver and client implementation for the LockManager case study. And as you can see, we're going to take a look at how this test driver is set up to make all these asynchronous calls to the LockManager service and what it does in response to those things. As usual, you can get this in my EX1 project in the WebFlux folder in my Live Lessons GitHub repository. And this particular chunk of code is in the test folder in that part of the project. So here we are in the test folder. You can see we have the client portion, which we looked at before. When we walk through the slides, that just creates the Lock API. Here's the Lock API. And now let's go ahead and take a look at LockManager tests. Now, this is kind of cool. It's a test that's going to test reactive features, but it's still going to be provided as a so-called SpringBootTest. So you can see it's going to know how to launch the LockManager application, which is the entry point to the microservice. And then it's going to have a defined port, which is going to be set over in the various parts of the application properties here. You can see port 880 is the port that's going to be used. And now we're going to auto-wire the Lock API to this field. That, of course, is going to call the client bean that we just talked about. So that's how we're going to get that put together there. And then we're going to have two test entry points. One is going to test the acquisition and release of a single permit at a time. And the other is going to test the acquisition and release of multiple permits at a time. And both these things could run in parallel. Doesn't really matter. That's just how it's up to the JUnit test apparatus, the harness, to decide how those things run. So the way this is going to work is for the test single acquire and release, we're going to have two locks on the server. We're going to get the server to create two locks. And we're going to have 4 client calls being made to acquire those locks and release them individually. So let's see how this works. We take the mlock API, we call create with max locks. Remember, create makes a call over to the LockManager application, the controller and the LockManager service field that, and it returns back a mono to a LockManager. And you can see that here with the type hint at the end of create. We then use the flat map method, which is a mono method, in order to be able to acquire and release individual locks in an asynchronous manner. So what we do is we create a flux, which will have from 0 to 1 less than max clients, which in this case is 4. So it's going to have 4 calls taking place here. It's going to generate 4 values. And for each of those values, we're going to call this helper method called acquire and release single locks, passing in the LockManager that we created by calling create and the specific client 0, 1, 2, or 3. And we're going to go take a look at that code in a second. And then we're going to collect the results into a list of void. This is just so it terminates and does something useful. And then we're going to block until all the asynchronous processing is done. So let's go take a look at acquire and release single locks. So as you can see, it takes the client ID, which is just used to differentiate the clients, and the LockManager. And what it's going to do is it will acquire the lock from the LockManager, acquire 1 lock asynchronously. So this call is not going to block. It's just going to be ready when we hit the terminal operation, and all these things are going to start flying over to the client side, and they'll all run asynchronously. If we succeed, we say what lock we got, and then we instantly turn around after we've acquired the lock and we release it. So we're just acquiring and releasing the locks. And if we succeed, we say that the lock was released with what result we got back. If something goes wrong, we print out an exception. And we use the .then method to indicate that we're done running asynchronously. And I don't actually run this on a background thread. I could. It wouldn't be hard to do. But I'm running all these things, and they're all going to be able to return right away. So that's what happens for single acquisition of locks. So now let's go take a look at multiple acquire and releasing of locks. In this case, we have 4 locks instead of 2. We have 8 clients instead of 4, and we're going to acquire 2 permits at a time. Once again, we start out by creating ourselves a LockManager. Then we use flat map on that mono, And now we're going to go ahead through 0 to max clients, which in this case is 8. So we'll have 0, 1, 2, 3, 4, 5, 6, 7. And for each of those values, we're going to acquire and release multiple locks. And we're going to get 2 permits. Otherwise, the rest of the code looks the same. So let's go take a look at acquire and release multiple locks. So what this does is it's going to acquire a max permit number of locks, a max permit number of locks. So it's going to make that call. Now remember, that call runs asynchronously on the server side. And once again, this is going to return right away. It'll return a flux of locks. And we then collect those into a mono to a list. So now we're going to have a list of the locks that we got back. And now we're going to take that list and we're going to release that list of locks and keep track of whether we succeeded or failed. So that's how we acquire and release the locks. So armed with that information, let us now run this particular test. Now, this throws out quite a bit of diagnostic information. And so once it compiles and runs, you'll see a lot of stuff flying by on the screen. And let's go ahead and take a look at this. So you can see here that test and release, test multiple acquire and release, that method starts first. And that is just happens to be the way that the JUnit decided to do that. It could have done it in the other order. If you look at the code, you'll see the single one actually starts first, but for whatever reason, it runs that one second. So we start off by testing and releasing multiple locks. And now you can take a look here and kind of see where things are happening. So some of the stuff that's being printed out here is coming from the server side. So lock controller create. You can see when that's called. This is running in a virtual thread in the server process. And it's coming out of a fork join pool of worker threads, because that's what we adapted it to use the underlying task, virtual thread task executor factory. And then it's going to create a lock with a count of 4 permits, and it tells you the name of this lock manager, and it tells you what the lock numbers are. This is just all diagnostic stuff. You can see 0, 1, 2, 3, and that runs in a virtual thread. And then that's going to be sent back over to the client. Now, once the client receives the lock manager, you can see that it's going to start up, and it's going to send a bunch of requests to the server. And you can see that these requests are running out of a pool of threads that's provided automatically by the underlying WebFlux framework. So we didn't actually have to create threads. There are threads that are created for each of these, or not threads that are created. There's a bunch of threads, and they run in different ways. Now, in this particular case, they're all running on the same thread. But if this was going to block, they could be running in different threads. So all these requests go over to the server, and now the lock controller is receiving those requests. And in each time, it's asking for 2 threads. For 2 permits. And you can see, once again, the threads that are being used to process those client requests. Number 64, number 66, number 63, number 67. These are all virtual threads that are being created automatically deep, deep, deep in the bowels of the Spring WebFlux runtime. And then over here, you can see that those are forwarding to the lock service acquire methods. And what you're going to see here is them going ahead and returning fluxes that contain the number of permits that are requested. And so that's taking place over here. And then you can see back on the client side, the various clients, client 3, client 4, is acquiring those locks. You can see that client 3 got locks 3 and 2. Client 4 got locks 0 and 1, just as long as they had them. And then they're releasing stuff after they acquire them. That causes the release methods to be called here. They're putting them back into the array blocking queue. And this goes on for some time as it's running back and forth. And it's all, mercifully, is all working correctly, even though everything under the hood is working in a very asynchronous way, and there's lots of non-blocking code and so on and so forth. So all that stuff ran, and we are done with test multiple acquire release, that test method. Then We start up test single acquire release, which is a lot simpler because it's only acquiring one lock at a time. So it's going to be a little simpler. But once again, we're calling create to make a semaphore with a count of 2. Then the client's going to start up, and you can see that it's got the number of the client that's being started. They're all running on this thread number 43. And if you take a look here, you can see that we sometimes are able to obtain a lock in a non-blocking way. And I think sometimes we get locks where we have to block. You can see down here we had to block because there was already other clients that had gotten the permit. So sometimes we get lucky and we don't have to block. Sometimes we don't get lucky and we have to block. But the key point here is it works properly, and the locks come back, and they're released and reacquired for as many times as the tests run. And when we're finally done, then it prints out we finished up with that. So rather more low level than you might want to have to parse through, but it's kind of interesting to see how this all works. And if you look carefully, you can see that things are running on different threads in the server, and on the client, they're all running in the same thread, although I could have adjusted that by making my client test have its own threads, which would have been trivial to do with the mechanisms that we get available with the Project Reactor features like subscribe on, for example. I could also have used parallel flux if I wanted to make it even more parallel. OK, so that is essentially the walkthrough of that code. Now, what's important to remember here is that for the next programming assignment, you'll have to figure out how some of these things work in the context of the database EX microservice that you're going to implement.